Welcome to your discussion post on effect measure modification. In this video, I'm going to briefly go over some important parts of this paper that you're going to need to read and understand to engage in your discussion post for this week. This paper is titled Age and Racial Disparities in Dialysis Survival. It's a really important paper that highlights the use of effect modification to understand health disparities. So I'm going to start off talking about the introduction in this paper. This initial part here gives you some background in terms of the importance of the topic. Something that you might want to look for when reading an article is the purpose of the study. So to find the purpose of any study, you really should go down to the bottom of the introduction. That's typically where that information is going to be included. So if you look at the bottom of the introduction of this paper, it talks about the purpose of this study. So you can see here it says the goals of this study were to 1. Examine age as an effect modifier of the racial disparities in dialysis survival, and 2. Determine if differential rates of kidney transplantation modify the risk of death on dialysis. So this paper has two goals or two purposes that it's looking at. We are going to focus on this first one, to examine age as an effect modifier of the racial disparities in dialysis survival. We're not really going to focus on that second one. So for your discussion post today, you'll want to focus on that first one. Moving into the methods, this was a cohort study that had a pretty large sample size. It had about 1.3 million people, and they got this data from the U.S. Renal Data System. It is a national registry. I want to point out that there's actually registries that exist for all different kinds of diseases. Oftentimes when healthcare providers, hospitals, any kind of clinical setting, when there's a diagnosis of a specific disease, it gets reported to a health department or whatever entity has jurisdiction in that area, and then that information is often reported up to a national registry. We have these for cancer, so there are registries for different cancer types, and so these are really important sources of data for conducting epidemiological studies. So this one is using the U.S. Renal Data System. Basically what they're doing is they're following people who were diagnosed with what we call ESRD. It's end-stage renal disease. That's a pretty serious diagnosis. Typically, if you get an ESRD diagnosis, you have to undergo dialysis on a regular basis, or you need a transplant. It's kind of the two options. So basically what this study did, it followed people who got an ESRD, end-stage renal disease diagnosis. It followed them over a period of time until death. In terms of what this study looked at, the independent variable is race, and the outcome variable is death on dialysis. So the way that you can think about this is that we're looking at essentially two groups in terms of race. We're looking at those who are white and those who are Black. The exposure group for race is going to be people who are Black, and the unexposed would be people who are white. The outcome is going to be death, and the people who don't have the outcome are going to be people who did not die. So when you think about setting up a 2x2 table to think about the exposure and the outcome, your exposed group would be people who are Black, your unexposed group would be people who are white, your outcome is going to be people who died, and then the people who don't have the outcome is going to be people who didn't die, who survived. I also want to point out that in this paper, they talk about population-based survival analysis. This means that they're including everybody in their sample. And as you go through here, you'll see they did a number of analyses, but this population-based survival analysis is basically the analysis they did. It's everybody in that end-stage renal disease registry data. And then they looked at some different analyses that they talk about in the methods section here. One of the things I want to go over and bring your attention to is this figure in the table. It is titled Figure 2. And this figure is telling us they use hazards ratios in this study. Hazards ratios, you can interpret them essentially the same way as like a relative risk. They're just a specific type of measure that we use when we have death as our outcome for very specific reasons. We use that hazards ratio, but you can think of it in terms of the same way as a relative risk in terms of interpreting that value. So a hazards ratio above 1 indicates a positive relationship, and a hazards ratio below 1 indicates a protective relationship. So this figure is showing us the actual hazards ratio of dying on dialysis, and it has been adjusted for several variables. So what you see here in this figure is this is our hazards ratio on this left side of this figure, and then we have these different age groups down here on the bottom. They have nicely drawn out this line for us. The 1 is going to be the null hypothesis, just as you would have 1 as the null hypothesis in a relative risk or an odds ratio. So anything that was above 1 would indicate a positive relationship. Anything below 1 would indicate a negative or a protective relationship. And what you see here is they've got these red dots. Those red dots are the actual hazards ratio. So the actual hazards ratio for this 31 to 40 age group here is somewhere between 1 and 1.25. These little bars here, these are the 95% confidence intervals. You can see that they're surrounding that hazards ratio. And the way that I would tell if any of these results here are statistically significant is I would look to see if the confidence interval includes 1. And I look at this figure, you'll see that none of the confidence intervals are actually they don't include 1. So for example, this hazards ratio is probably, I don't know, somewhere between 1 and 1.25. Let's call it 1.1 for simplicity. You'll see that it's about 1.1, and then I've got that 95% confidence interval. It does not include 1, so it looks like there's a statistically significant relationship between race and death on dialysis. And it's a positive relationship. So if I were to describe that relationship, I would say it's a positive relationship. That hazards ratio is above 1. I would have a similar interpretation for this youngest age group. I see that those results are statistically significant. This 95% confidence interval does not include 1. So I would conclude in the 18 to 30-year-olds, there's a statistically significant relationship between race and death on dialysis. If I were to describe that relationship, I would say it's a positive relationship, meaning that being Black is going to increase essentially your risk of dying on dialysis. So being Black is essentially a risk factor for dying on dialysis in this 18 to 30 and this 31 to 40 age group. What you see is a little bit different for these other age groups. You see that this hazards ratio is well below 1. These are all protective relationships, meaning that being Black is actually protective against dying on dialysis. And all of these results are statistically significant because none of these include 1 in that 95% confidence interval. So hopefully this brief overview was helpful in understanding some of the key components of this paper. Now you can engage in your online discussion post. It's okay if your answer isn't totally correct. I'm going to be engaging in that discussion post with you and helping to clarify some of the points if anything's confusing or if anything seems off in your response. So this is a respectful environment, and I hope all of you are able to engage in a meaningful discussion post where we all learn together.